Good evening, Ritika.
Good evening, ma'am.
The school has started the last chapter, that is redox, or not as yet?
They completed it today, ma'am.
Completed how many classes?
Full day.
Entire day?
Yes, ma'am.
What are the concepts they taught you? Do you remember any one of them?
No, ma'am.
Okay. I was thinking, how can I complete it? But since you may be now knowing some of them, so we can think of your exams are starting from, I think you told me, but I'm so sorry, I forgot it. When are your exams starting, Ritika?
Feb 12, ma'am.
12. Okay. So we'll be covering the last topic of that chapter, equilibrium first, that is solubility product. I believe it is taught to you in your school. Usually we get a numerical from this particular section of the chapter. Today is, I believe, 7th, not 6th. Now, we must remember that solubility product is a concept which is related to sparingly soluble solvents or substances, to be more precise, right? I have put a cross here. It will not be applicable on sodium chloride or magnesium chloride, right? In the last class also, we discussed that the substances which dissociate, which are said to be weak compounds or acids or bases, they dissociate to maximum 3%, right? So similarly, you have a compound which is named as silver chloride. It dissociates maximum to the 3%. That is why we say it is a sparingly soluble salt. So potassium, it will dissociate to give us silver and chloride ion. If I ask you to write, or even if I if I write the expression for K or KSP, what do we get? We get K is equal to concentration of product upon reactant, right? Then we say the concentration of silver chloride written here will be a constant because it's a weak electrolyte. It will dissociate maximum to the 3% only. That means the amount of silver chloride which has remained undissolved. I believe you remember that on the product side we write the formed, and on the reactant side we write the compound or the quantity which is remaining over there, right? So, so it reacts with this specified or the fixed amount of silver chloride. So that means, again, like we have done in the last class about the derivation of Ka and Kb, that this K, the value of K, which is a constant, whereas the value of AgCl is also a constant, right? So when you multiply the two constant, you get another constant, which is called as Ksp, or the solubility product. So what we have learned here is that first of all, the concept of solubility product is applicable only to the sparingly soluble salts, but it will never be applicable to completely soluble salts such as sodium chloride, magnesium chloride, or copper, or maybe calcium sulfate, like that. So when we are deriving this deriving this expression, we need to just write the equation for the dissociation, write the value of K, substitute the values, and get the formula for Ksp. Now, we must remember it, or this is what I have told you already, that from the reactant side, you'll be writing whatever is left out, and from the product side, you will be writing formed, right? Now, what is X here? We can, it's upon your wish whether you want to take it as X or you want to take it as S. So if we say, let the solubility of AgCl be equal to X grams per liter, right? So when you write the expression for Ksp, I believe it is clear. We'll be writing it as Ag plus and Cl minus. Now, the amount of Ag plus formed will be equal to X because that much has dissolved only. And for silver, similarly for chloride ion, it will be again X. So what we can say, Ksp will be equal to X square. The questions are not that difficult. Of course, they are there. That's the important thing, but not that difficult. They either give you the value of X and ask for Ksp, or they give the value of Ksp and ask for X. Is it clear, Ritika?
Yes, ma'am.
Okay. Now for the other compounds, we need to find the expression first. Ksp will never be a fixed formula. Like as you can see, if we have the compound of this category, let's say A to B, I'll be deleting rest of them. If we have a compound of category A to B, or we can call it as AB2, right? For example, we have MgCl2. What will happen? It will dissociate to give us Mg2 plus ions and chloride ions. Of course, 2 chloride ions will be produced by it. What will be the expression for Ksp? That will be, let us put it at a proper place. Ksp will be equal to concentration of magnesium ion into concentration of chloride ion to the power 2. Why 2? Because you have 2 here, right? Now, assumingly that the solubility is X grams per liter, right? That means how much magnesium will be formed? That will be X. And how much chloride? That will be 2X. Now, if you substitute the values here, so what you are going to get? You will get Ksp will be equal to 4x cube, right? If somebody asks for what will be x, you can do the mathematical operations to find the answer. Similarly, for Finding the KSP, you also know how to do it. Simply put the values and get the answer, right? So in these type of a question, it is important for us that we find the relationship. Solubility product will never have a proper formula in the sense that it is equal to K is equal to C alpha square, like we did in the last class. It will never be that, right? Now, if you have I can just generalize it that this is a salt which is producing two ions, silver and chloride. Any compound which on dissociation is going to produce two ions, then the formula will be KSP is equal to X square. But if something is producing three ions like this one, MgCl2, then the formula will be this. Then similarly, if we have a compound like this, let's say AB3, right? What this can be? It can be, let's say, AlCl3. It will dissociate to give us aluminum ions and three chloride ions, right? Concentration of this will be X, assumingly we are taking the same benchmark, that X is the degree of solubility, and this will be 3X. The expression for KSP will be concentration of aluminum ion and concentration of chloride ion to the power 3, as I have explained it to you in the earlier slide also, right? Here what you will be writing? Here you will be writing X. Here you will be writing 3X cube, right? So what we have? We'll be having 27X to the power 4 is equal to KSP. You will, again, I say the same thing. You will be given the value of KSP or you will be given the value of X. Is it clear, Ritika?
Yes, ma'am.
Okay. So these are the just, see, this is what I have solved it for you. KSP is equal to root 3 upon KSP by 4, right? So there can be many questions for this, like Ag2SO4. You must remember here that Ag2SO4 will produce how many ions? Total of 3. Twice Ag plus and SO4 2 minus ion. So its expression has to be something as you got it for MgCl2, right? So with that, we end the chapter of equilibrium. I'm sure that we have covered every topic and subtopic of it. Do you have any issues in any one of any topic, or just to ensure that whether we have learned each and every topic of this chapter? Anything missed by me? Please remind me, Ritika.
No, ma'am.
Okay, now you can do the questions based on it. I am not going to give you right now. Don't worry about that.
Yes, ma'am.
Okay. Now it's time to know or complete the chapter of redox reaction. I don't know at what speed they have taught you, but I have listed all the topics. I'll be teaching you all the concepts. Only you will have to do the practice. I'll probably be giving you the assignment to you, 1 or 2 assignment or the 1 or 2 full-length tests, so that you can cover and you can be confident about your final exams. So we know what is a redox reaction. That's a concept of class 10th. We know what is reduction, what is oxidation. Do you know, Ritika? Okay. Let us explain each and everything one by one. Not going against the time, but not racing against the time, but trying to tell you what it is. Redox reaction is a word which is made up of two reactions, or which comprises of two reactions. One is reduction and the other one is oxidation. right? Reduction and oxidation, as you might be familiar, can be defined in various ways. One of them is in terms of oxygen, right? A reaction in which oxygen is added is referred as oxidation reaction. And the reaction in which the hydrogen is removed is referred as oxidation reaction, sorry, right? So this is, I'll say, of class 10th. If you reverse this concept, a reaction in which oxygen is added is oxidation. That means a reaction in which oxygen is lost will be referred as reduction, right? Or before that, let us see, there can be many other ways. A reaction in which electronegative atom is added. Oxygen is electronegative, so that makes a bit more sense to understand oxidation reaction in that term also. And it can also be referred as a reaction in which electropositive element is removed, right? Loss of electron is oxidation, loss of, sorry, I need to take a break. We will do it in a summary first, then probably we will take it in a detail. Because that will take a lot of time and we know each and everything. Is it too difficult for you to understand any one of the concept, Ritika? To the best of my understanding, I'll put a tick mark at certain places. This, and this is something which you are taught in class 10th, and I believe you must be very clear about it. But if you do not understand, I'll take 5-10 minutes to explain that, because the entire chapter is on redox reactions. Unless or until we understand the basics, we may probably not be able to proceed further, right? So just let me know, oxidation is gain of oxygen or addition of oxygen. It can also be defined in terms of hydrogen as loss of hydrogen, or we can say removal of electropositive element, or we can say it is addition of electronegative element. Loss of electron is oxidation, increase in charge of the element is oxidation. That means I'm talking about the last point. Fe2 plus is converted into Fe3 plus, right? By the loss of one electron. I can write this reaction like this, or I can write this reaction like this. Is it making sense, Ritika?
Yes, ma'am.
Okay. So I don't think there is a need to go to each one of the examples, because they are pretty clear and they are concepts of class 10. So there is no need to go through them, although the presentation will be saved on the servers and that can be shared with you, right? So you can always refer back to them. And more importantly, I'll say that refer to what your teacher says. Teacher says means that whatever she has emphasized. I know this thing may not be emphasized in her notes, but this must be there, because this is the basics. We will come back on it, competitive electron transfer, towards the end of the chapter, because otherwise it will change, or it will not be a happy scene to do that. Then similarly, you must be knowing what is an oxidizing agent and what is a reducing agent. A substance, for this, that's what I say. It is very important for, as a class 11th student, we must remember that loss of electron is oxidation. Anything which undergoes oxidation will be a reducing agent. Just remember they are opposite of each other, right? Similarly, if something is gaining an electron, if I talk about this, right? A reagent that causes reduction is called as the reducing agent. I'll put the same definition here. Loss of electron is oxidation, and reducing agent undergoes oxidation. Right? I understand, Ritika, you are having a overdose of redox, but try to understand. I can just request you to do so. You just have to remember those definitions. You might be asked in the paper that which one is oxidizing and which one is a reducing agent. That's important, right? Then quickly moving to the next concept, that is pretty easy. We say that redox reaction are those in which there is a change in oxidation numbers. We say that they are of 5 types. But before we understand that why certain reaction is an oxidation, redox reaction, or why not, first of all, we must understand what are the oxidation numbers. Although I have put this class in the same order as in the book, in NCERT precisely. But unless or until, I believe if I tell you what are the rules for finding the oxidation numbers, you cannot do the justice with this, right? So I will split this one into 2, and I will say that, Ritika, this is the most important part of the class. Because if you do not understand how to find the oxidation number, you won't be able to balance the reactions. And balancing the reaction is the most tricky and the important part. It is a sometimes 3, 4, or even a 5-mark question. So first of all, let us understand these rules one by one. Rule number 1. Pay attention to rule number 1, Ritika, which says that every element in its free state or every substance in uncombined state will have oxidation number as 0. That is very important, right? That hydrogen exists as H2, oxygen exists as O2. That means its oxidation number, whenever if I write that H2 plus O2 gives us water, oxidation number of hydrogen is 0, as well as that of oxygen is 0 in this case, right? This we must remember. Phosphorus is P4. Why? Because phosphorus exists as P4. Sodium is S8, so not sodium, sorry, sulfur is S8 because it exists as, sulfur is a polyatomic molecule, it exists as SH molecule, right? Quickly moving on to the next point, which says for ions, it will be equal to the charge. Say, for example, if I have written copper 2 plus, so what will be the oxidation state of copper 2 plus? Copper in copper 2 plus will be 2 plus. If I'm writing copper plus 1, that will be plus 1. Is it clear, Ritika?
Yes, ma'am.
Okay. Then you will see that there are certain exceptions. Then the most important thing is that oxygen is taken as -2, hydrogen is taken as -1, and the moment we say, we talk about the exceptions to this rule. Here in the rule number 3, we are going to use our periodic table. We have learned the periodic table just to know more about the oxidation numbers, right? The elements of group 1, 2, and 3. Group 1 is lithium, sodium, potassium, rubidium, cesium, francium, and group 2 is beryllium, magnesium, calcium, strontium. Group 13 is aluminum, boron, aluminium, gallium, indium, thallium, like that. So for group 1 elements, their oxidation state will be +1. Suppose I'm writing NaCl. In NaCl, the oxidation state of sodium will be +1. That of chlorine will be -1, right? So that's how it is going to work for us. There are exceptions for oxygen as well as hydrogen. So first of all, the basic rule says that oxidation number of oxygen in general will be -2, except for the fact when we talk about H2O2. In this document, you will find there are many sub-superscript errors. I'll appreciate if you can just ignore them because it's a typing and what I say, they have transformed one content from the other page. It's a copy pasting error, I will say. So I'm so sorry for that, but please bear with it. Being a chemistry student, we just understand what it can be, right? But you have to remember these two exceptions. In case of superoxides, right? And peroxides, the oxidation state of oxygen will be different. In peroxide, it will be -1. In superoxides, it will be -half. So I have put that in red so that you remember that you have to remember that. Remember that usually we get a question from the exceptions only, right? Whatever is a straight line, all clear, easy, then there will be no questions, right? Moving to the next rule. Now we'll be talking about rule number 5. For halogens, we say, or specifically for fluorine, we say its oxidation state is always -1, right? But in case of OF2, the compounds of oxygen and fluorine, what happens in that case? OF2. Now, fluorine, if you remember, go back to the periodic table, recall where what we did, that we said that most electronegative element of the periodic table is fluorine, right? And therefore, it is always having a -1 oxidation state, except for the compounds like OF2, O2F2, that where the oxygen is bonded to fluorine, that oxidation state of oxygen is going to be positive, right? So we have learned 3 exceptions for oxygen. One is superoxide, other one is peroxide. We have done it on this sheet. Peroxide is -1, superoxide is -half, and in case of this OF2 or O2F2, it is +2 and +1. So do remember that oxygen may have a positive oxidation state, right? Then the last but the most important one is that the sum of oxidation state of all the elements in a given compound is equal to 0. And if it is an ion, that will be equal to the charge, right? So, and I think I cannot see that the hydrogen's rule. I will just write or I will add that hydrogen wala rule, that in case of hydrogen, hydrogen is always taken as +1 except for hydrides. In case of hydrides, the oxidation state is -1, like sodium hydride, right? Except for hydride of group 1, right? It will be minus. It will be the opposite of +1, that is -1. Now, let us do certain examples to have more clarity about it. We will be finding the oxidation state of carbon in it. Let's say we have to find the oxidation state of nitrogen in NH4 plus. Then let us find the oxidation state of manganese in KMnO4. And then finally, chromium in K2Cr2O7, right? Or, yeah, that's all. That will give us enough practice. Start finding out, Ritika. We will not be doing a practice of the exceptions, because exceptions are to be learned by heart by you, right? And you have to reproduce or you have to write them during the exams if asked. Found the oxidation state of any one of them, Ritika? Okay, let me solve this for you and see whatever element is underlined, we have to find the oxidation state of that. In this case, it is carbon, and that is assumed as X, right? Then we say the sum of oxidation state of an element is always 0. Let's do this one first then. KMnO4. We know potassium is an element of the first group, so its oxidation state is going to be +1. For manganese, that will be X, right? Because that we have to find out. Oxygen, I have told you it is -2. So that will be -2 into 4, because it has got 4 oxygen. That will be equal to 0. That's what we have learned, that the total sum of oxidation states of various elements is 0, right? So if you solve that, what do you get? I believe you will get 7. Clear, Ritika?
Yes, ma'am.
Okay. Now talking about K2Cr2O7, it is interesting because you have got 2 chromium atoms here, not 1. So what we will do, potassium is 2 potassiums. So what we will say, potassium is +1. There are 2 potassium atoms, so I'll be putting it as 2 into +1. For chromium, we'll be saying it is 2x. It's not 1 chromium, there are 2 chromium atoms. So we'll be putting it as 2x, right? And there are 7 oxygen. So it is -2 into 7. So what do we get? And the entire sum will be equal to 0. So what it will be? This will be 2 plus 2x minus 14 will be 0, right? So 2x will be equal to, that will be equal to 12. So x will be equal to +6. Right, Ritika? Then we move to NH4
ma'am.
plus. Okay, thank you. We'll assume nitrogen as X. There are 4 hydrogen, 1 hydrogen plus 1. So what we will do? We will multiply 4 by +1, and the resultant has to be equal to +1. If you are having a charged species, then that has to be +1 or -2, whatever it is. So we are given a +1 charge. So what instead of plus, I will be preferring to write it as 1. So x will be equal to, this will go that side, that will be equal to -3, right? Now moving to the first one, I thought that was a pretty difficult or offbeat. So I thought I will do rest of them first, right? Carbon is X, oxygen will be minus 2 into 3 equal to minus 2. X minus 6 is equal to minus 2. And that will be equal to 4. Have I made any mistake, Ritika and Carbonate? Just cross check, is the carbonate is correct? Any issues, Ritika? Not able to understand? Please ask me. I'm still waiting. Done, Ritika? Okay. Before moving to the next topic or the previous topic, which I thought I will be teaching you later, later means now. Before doing this, we must remember during oxidation reaction, oxidation number increases. And that means during reduction, the reverse of it will take place. Oxidation number decreases, right? So conversion of Fe2 plus into Fe3 plus, what it will be? Quickly, Ritika, is it oxidation or reduction? Tin 4 plus converting into tin 2 plus. Just pay attention, Ritika. Oxidation number is increasing. For iron 2 plus, it is 2, and iron 3 plus, it is 3. So oxidation number is increasing. So the first case, conversion of Fe2 plus into Fe3 plus is an example of oxidation reaction. This one is an example of reduction reaction, right? Now, if it is clear, only then we will be able to understand the rest of the topic, which says that redox reactions can be classified into basically 5 categories, like combination, decomposition, displacement, disproportionation, and proportion. That we will leave. We will just talk till disproportion reaction. The last one is not in your syllabus, at least your CBSE syllabus, right? So when two elements, this is pretty simple. When two elements are adding up or combining, and their oxidation numbers are also changing, right? One is being oxidized, another being reduced. As you can see on my screen, magnesium is the oxidation number of magnesium is changing from 0 to +2. That is increase in oxidation number. Whereas in oxygen, the oxidation number is changing from 0 to -2, right? So that means in one case, the oxidation number is increasing, magnesium to magnesium 2 plus, oxygen to O minus 2, it is decreasing, right? So this is an example of redox reaction, redox combination reaction, right? It is not necessary that every reaction is a redox reaction. We'll come to that example. Now talking about the decomposition reaction. Again, decomposition means the breaking down of a molecule into smaller parts. So what is happening here? You are reducing them, right? You are changing them. Sodium hydride is converting into sodium and hydrogen, right? Na plus one, changing from +1 to 0, and hydrogen is changing from -1 to 0. I understand it's pretty theoretical, and you need a lot of concentration to it, but I'll still say, Ritika, you will definitely get 6 to 7 mark question from redox, right? So I have written the other example also. Quickly copy both the examples so that I can move ahead. Okay. Then displacement reaction. One metal displaces the other metal from the salt, or the one metal non-metal displaces other non-metal from the salt. So we say that displacement reactions are of two types. One is metal displacement, another one is a sorry, non-metal displacement reaction, right? Again, you will see copper sulfate copper being oxidized to copper 2 plus, and zinc being oxidized to zinc being reduced to zinc 2 plus, right? I believe it is making sense, Ritika. Moving on, we will be having a non-metal displacement reactions, right? When the hydrogens are displaced by alkali metals, there can be a displacement reaction involving only halogens, right? In this case, we are just talking about hydrogen. You just have to copy down the examples. Again, it's a good 3-mark question in the paper. You are given 5-6 reaction asked to classify them, right? So you can understand that hydrogen is being displaced, or hydrogen is being prepared or given out in this reaction. Most of them, whichever is available, either calcium or zinc or iron, we react with them, we react water with them, and then get hydrogen, right? Now talking about the halogens, more reactive halogen will displace the less reactive halogen from its salts, right? So we know that, again, we have talked about group 17, we have talked about the reactivity in periodic table. So we'll be saying fluorine is most reactive, and the order of the reactivity of nonmetals is written at the bottom of the slide. Most reactive being fluorine and least reactive being iodine, right? So if you react any one of them, any of the compound of chlorine or bromine, like potassium chloride or potassium bromide, chlorine and bromine will be liberated. This you might have done it in the form of a layer test in your lab also. Have you done the layer test, Ritika? Okay. These can be seen in the form of layers when you are performing the test. So therefore, it is called as a layer test. Even if you have not done it, it's important for you to remember the name of the uh, gases liberated and their colors, right? Like bromine is a reddish brown colored gas, or a liquid it can be, and iodine is violet colored, right? order of reactivity of halogens, as I have already told you. Like we have in non-metals, or sorry, in metals, more reactive metal displaces the less reactive metal. Similarly, more reactive non-metal will displace less reactive non-metal from its salts. Then disproportionation reaction. This to me is the most important one from the perspective of the short notes. That what is a disproportionation reaction? A reaction in which the same substance undergoes oxidation as well as reduction, right? For example, you can see hydrogen peroxide is being converted into water and oxidation simultaneously, or we call it as simultaneously, whichever way you feel like. So oxidation number of oxygen in H2O2 is -1. In one place, it is being converted into 0, right? That is, it is increasing. Increase in oxidation number is oxidation. And in the second case, it is decreasing. That H2O2 is being converted into water, where the oxidation number is -2. So please note it down, Ritika, that disproportionation reaction in which the same substance undergoes oxidation as well as reduction. Okay. This is another example, right? That this is again very commonly asked question, that this one is, which is oxidized and which is reduced. Chlorine reacts with a base. OH minus represents a base to give us ClO minus ion, Cl anion, that is chloride anion, and the water, right? So this is another example. And the last point on the screen says that this reaction, the fluorine compounds will never undergo disproportionation reaction. Why? Because fluorine shows only minus oxidation state, right? It can never show us the positive oxidation state, because again, it is the element having the highest electronegativity, right? Then we will not be talking about these reactions because they are not a part of a CBSE syllabus. We have already done oxidation number. Now coming to the quickly to the next topic of to be discussed is that balancing of redox reactions. Ritika, just I'll be very happy if you tell me, have you been taught about both the methods, or they have taught you only one method? Ion electron method or oxidation number method, or both the methods?
Ma'am, they taught the second method, ma'am.
I didn't get you. Can you please repeat, Ritika?
Ma'am, they taught us the second method, oxidation number method.
Okay. So I believe the possibility is that ion electron method will not be coming in the exam, or we still need to do it. Okay. We'll quickly see, there is nothing great into it. Great in the sense, there is of course a degree of difficulty attached to it. You have to know, for both the cases, you have to know both the rules and then you have to apply them, right? With the help of both the methods, you can balance the reaction and then uh, use them as and when required, right? So talking about but for that you must know the rules, right? So if I talk about the ion electron method, we say that split the reaction or the given reaction into two halves: oxidation half reaction, reduction half reaction. Then balance the oxygen and hydrogen. I'm so sorry, Ritika, you have to learn these rules, right? If you want to copy it down, I can wait for you. You can copy it down. Or I will tell you when I'm explaining I will take the example, one example each of both the categories, so that they become clear to you, right? So the first step is write both the half reactions. Second step is balance all the atoms except oxygen and hydrogen. Next, they say for oxygen, you'll be using water to balance it. And for hydrogen, you'll be using H plus ion in the acidic medium, right? Because acidic medium will have excess of H plus ion. But if they say the reaction is to be balanced in the basic medium, that is, you are given, let's say, solvent is there, which is a base like potassium hydroxide. So that means there will be excess of OH minus ions, right? So in the basic medium, you have to add water on the side where H is deficient and add equal number of OH minus ions on the opposite side, right? That's a simple rule that you can remember once you do a lot of practice, right? Then what we have to do? Then you have to balance the charges by adding the electrons wherever required. Then equalize the electrons and then add the two half reactions to get the overall reaction, overall balanced reaction. Then you have to verify whether the reaction is balanced or not. We'll just take this example quickly, this reaction. The reaction can be given in this form, the upper one or the lower one. What I do is I simply take, see, the first step is common to both the categories of balancing the reactions. If you look at this carefully, you will understand that chromate ions, dichromate ion to be precise, Cr2O7 2- is a dichromate ion. It is being converted into chromium, right? And then the second one is SO2 gas is converted into SO4 2-. One by one, we will see what is happening. So first step, we are clear that we will be writing both the half reactions, right? Now, what was the second step? They said that balance all the atoms except, first of all, we have to balance chromium, right? For balancing chromium, what we have to do? We have to put 2 over there, right? You can see here, balancing atoms other than oxygen and hydrogen. So you will notice the change only in the dichromate reaction that where you have put up the 2. Then you have to balance the, let me take it separately so that see, the first step says balance all the atoms except oxygen and hydrogen. So we can see there is oxygen, chromium atom is there. So what I will do in the first step, I will write Cr2O7 2-, changing to Cr3+, and I will add 2 before it. Then I have to balance the oxygen atoms, right? For balancing the oxygen atoms, what I will do? I will add 7 water molecules on the opposite side of it, right? So I can write it separately that Cr2O7 2-, I will write 2 Cr3+ and add 7 water to it. Now, water is oxygen is balanced, right? But what has happened? I believe you understood why I have added 7 water, because I need 7 oxygen atoms. But in that bargain, what I have done? I have taken 14 H atoms are there. So what we have to do? We have to put 14 H plus on this side. So this will be 14 H plus Cr2O7 2-, changing into twice Cr3+ plus 7 water. Now, if you count them carefully, you will understand, Ritika, that by doing so, we have balanced the atoms, but the charges are not balanced at all, right? So before we balance the charges, let us first of all balance the other half reaction also. So the other half reaction was this. Let us copy it there to this point at least, right? So that if we go by the rule book again, the first step is to balance all atoms except oxygen and hydrogen. We can see sulfur is the other atom which is already balanced. What we have to do? We have to balance oxygen, right? So one side has got 2 oxygens, another one has got 4 oxygens. So what we have to do? We'll be adding twice H plus. So rather, sorry, 2 water. 2 water plus SO2, what it will give? It will give us SO4 2 minus, right? So you will have total of 4 oxygen. Now in this bargain, what we have done? We have again got 4 more H plus ions. So to balance the atoms, what we have to do? We will be saying twice water plus SO2 gives us SO4 2 minus plus 4 H plus ions, right? Is it clear somewhat, Ritika, to you? Now the next step is, now the atoms are balanced, we have to balance the charges. For balancing the charges, what we have to do? We have to count what are the charges over there. In this case, we have 4 positive and 2 negative charges there, right? If we cancel them, what we can get? We'll say we got a 2 positive charges here. So to balance these 2 positive charges, what we have to do? Let's see here what we have to do. We will be, look at the first reaction. You will be adding the 2 electrons like this, right? So we'll be balancing the I'll put it on a full screen so that it is more clear. As you can see, now the left-hand side of the reaction is balanced with respect to the charges. Look at the top, the first reaction. Point number 4, right? SO4 2 minus has got 2 negative and 2 electrons have also got 2 negative. So there are 4 negative and 4 positive. They are cancelling out each other. Look at on the other side of the reaction where we have added 6 electrons, right? To make the reaction electrically neutral. So oxidation, this one will be called as reduction half reaction. When I was balancing the reaction, I never put the names as oxidizing or reducing, oxidation half or reduction half reaction. Why? Because when you balance them, you realize, okay, wherever you have added electron, that means addition of electron is reduction and loss of electron is oxidation, right? Now at this step, look at the reactions, look at the 2 half reactions carefully, Ritika. You will come to know that in one part of the reaction, you are having 2 electrons and in another part, we are having 6 electrons. We understand that electrons do not have an independent existence, right? So what we have to do? We have to make the number of electrons equal. What we have done till now? We have balanced all the atoms. Hydrogen, oxygen, chromium, sulfur, whatever were there, we have balanced the atoms. Then what we have done? We have balanced the charges, right? And then what we have to do? We have to make sure that there is no free electron. All the electrons are balanced, right? So that is why, look at the reaction number 5 or the 5th part of the screen, where what we are saying, we will be multiplying the entire equation number, the oxidation half reaction by 3, right? Because that will give us 6 electrons, which are equivalent to the second half reaction, right? So both the reactions are now having 6 electrons, one on the reactant side and another one on the product side. Now, now what is left to be done? You have to add all of them, right? When you are adding them, whatever is common, like you can see 12H plus on the product and 14H plus on the reactant side. So you can be smart enough to say the overall will be 2H plus like this, right? I hope it is clear. I will teach you the oxidation number method also. But you should be knowing both the methods. You should remember all the rules, because many a times it is written in the book, in the paper, that which method they want you to apply, which medium they want to apply. If they are not, they have not given that which medium to apply, you should always go for acidic medium. You should never go for balancing the equation in the basic medium, right? Okay. Now, we'll be doing the other method, that is oxidation number method, right? Probably you'll be more interested into it. There we have balance with using electrons. Here you will be using the change in oxidation number. Change in oxidation number in both the half reactions must be similar, right? So if you are given this particular reaction, where magnate ion reacts with chlorine to give you this, right? So first of all, you have to write the oxidation number. The only reason for us not being interested or not being able to understand it fully will be that we are not too sure about how to get the oxidation number. MnO4 2 minus, I think now you can find it out. MnO4 minus also, Cl minus also. You have to write the oxidation number of each one of them, right? And then you can mark which element is undergoing the change. So MnO4 2 minus, in this case, oxidation state of manganese is +6. I think if your maths is good, you can, just by looking at it, you can, and with some practice, of course. O4 means -8, and it has already got -2 charge. That will make it as +6 ultimately, right? So you can see what is happening during the reaction. Mn +6 is changing to Mn +7, right? That means oxidation is taking place. Oxidation number is increasing. O4 2 minus, what is happening? Cl2. Oxidation number is 0 now, which is converting into Cl minus, -1. Oxidation number is decreasing. That means reduction is taking place. Quickly copy it down, Ritika. It is, as you said, it is important for you because oxidation number method is being taught in your school. At least copy down this example, Ritika. That will help. Okay, let's move to the next part of it. What you have to do, you have to know to find out what is the change in the oxidation state. That's what I have. Oxidation numbers to be precise. +6 to +7. That is change of 1. And 0 to -1. Again, there is a change. Let me see. Okay. Why we have to write it as 2? That's the question. Yeah, that becomes a problem sometimes when you are doing oxidation number method. There are 2 chlorine atoms. So first of all, you have to make it as twice Cl minus, right? One atom will be making a change of -1 and the 2 atoms will be making a change of -2. So that means it will be wise if I put 2 itself here in front of this chlorine here, right? So then the change in the oxidation number of 2 is justified. So I believe you will be very careful when you are solving it, Ritika. That's a word of caution from my side, right? Although this step is not written in the oxidation number method, but that's logical, that you have to balance all the atoms other than uh, oxygen and hydrogen before you move further. Manganese is fortunately balanced, but when you balance chlorine, you have to put a 2 here, right? Just quickly note down here so that I move to the next one. Now, as you can see, in one reaction, there is a change of 2, and in the other one, there is a change of 1. So what you have to do to equalize the changes, as we have equalized the electrons in that method, you have to multiply that MnO4 2 minus changing into MnO4 minus 1 by 2, so that you will get this, right? You will balance all of them, and hence you will get the balance equation, right? Clear? Making sense, Ritika?
Yes, ma'am.
Okay. Now, this is you have to, I believe you might not have been taught about it. Just remember that we use most of the redox reactions in the titrations. You, in the practical classes, must be doing a acid-base titration, right? There, the redox reactions are taking place. That's the one important thing about it. Now, then we were in the beginning of the, or towards the initial part of the lesson, I said we'll be taking up in the later half. That was a competitive, this section, competitive electron transfer. For this, there is a chapter in class. Have you been, has your teacher touched this topic of electrochemical cells, Ritika, or not? See, I'm touching on this topic because it is given in the NCERT. They say because the metals have different electrode potentials, they can give the electrons to one another, depending upon who is more powerful at a particular temperature and pressure, or under the concentration of a ions, right? So the batteries which we use are example of electrochemical cells. In the competitive electron transfer, they say if you have zinc and copper rod, which are dipped in a which are dipped in a cell, which are dipped in a electrolyte, right? The electron are transferred from zinc to copper. It gives out 2 electron like this. But if you connect copper and silver, the electron are transferred from copper to silver. It seems a bit confusing, not only to copper, but to us as a student or a teacher also. So we say, like in the classroom, you may be having certain marks more than the other student or certain marks less than the other student. That is how it works. That I stand third in the class. That means I have 2 students who have scored more marks than me, and I may be having, let's say, 40 students who are behind me, right? I can be proud that I know more than the other 48 students, but I need to think about myself that I know slightly lesser than the students who have scored more than me. So similarly, we say that there is uh, always a competitive electron transfer, right? So that's what we say, that when we dip zinc rod in copper sulfate solution, electrons move like this, and copper gives electron to silver. We use a technical term, we say it as an electrode potential. We say whenever we use a metal in an electrolytic cell, they have drawn an electrolytic cell. Also, I'll move to the next slide there where I have also drawn it. Whenever there is a electrode is just like a rod. You have a zinc rod dipped in zinc sulfate solution. We call it as a electrode. You have a copper rod dipped in copper sulfate solution. That is called as copper electrode. The idea is that you will be putting the metal rod in the solution which is having a common cation, right? If you want to make a silver electrode, you will be putting the silver rod in silver chloride, maybe silver nitrate solution, right? So I believe this section is clear, that there will always be a tension on the surface of a metal, that whether it is going to give the electron or whether it is going to accept the electron. And that is called as electrode potential, right? So this is how it works. So we say on the basis of this, we can make a electrochemical series. According to this, we say zinc is most reactive because it is giving out electron, right? And to whom it is copper. And between copper and silver, copper is giving electron. So copper is more reactive than silver. I believe you understand it from the shorter format, that between zinc and copper, zinc has the upper hand. Zinc is more reactive because it is capable of giving out the electron. Between copper and silver, copper is more capable, right? So that means from these two reactions or from these two cell setups, we can say the reactivity is that zinc is more reactive than copper and copper is more reactive than silver. Just note it down.
Hello, Moto.
बेटा पढ़ा रही हूँ कुछ अर्जेंट.
एक जो डेटा वो देना था ना कॉलिंग का ऑफिस में. हाँ, वो मुझे मेरी ड्यूटी थी, कल से दी गई थी. कल मैंने नहीं शेयर किया क्योंकि मैं बहुत बिजी थी. आज मैंने जान करके नहीं शेयर किया क्योंकि मैं बहुत बिजी थी. तो और वो मेरा आया था उससे कि भेज देना. तो मैंने कहा था भाई ये भी शेयर ना, मुझे भी शानी ने दिया ना मैंने अपना था. तो मैं सोची थी कि मैंने टीम से टेक्स्ट कर दूँ या रहने दूँ, इग्नोर करूँ, मैं कल सुबह दूँ.
अभी इग्नोर कर दो, मैं पढ़ा रही हूँ. I hope you have noted down, Ritika. This type of a question, if they have taught, that may come. Anyways, it is there in NCERT, the details. I may be knowing this much big thing, or maybe in the class 12, you'll be understanding this much big, so many things. The chapter number 2, electrochemistry of your syllabus. But as of now, we don't have to do much of the things about it, right? This is how I have taken it from my class 12 content, where we talk about them in detail. Just to make you acquainted about the terminologies, we call zinc copper cell is called as a Daniell cell. electrode potential, I have explained it to you. Zinc dipped in zinc sulfate solution will be called as 1/2 cell, and the copper dipped in copper sulfate solution will be called as another half cell, right? 2 half cells will combine together to give us a complete cell or complete electrochemical cell, as you use in when in your, let's say, the remotes, the TV remotes, the AC remotes, all of them, they have a cell, right? So then these are the finer nuances of it. That what is a direct redox? There will be a direct and indirect redox reaction. I have drawn the picture of a direct redox reaction. This one is a direct redox reaction when zinc and copper, both the electrodes are dipped in zinc sulfate solution. And the other one, which I have taken from NCERT itself, this one is a indirect redox reaction when both of them are given a separate container, right? So basically, we just have to understand what zinc is a which type of electrode, copper is what type of electrode, positively or negatively charged, right? So I don't think there is anything else left in the chapter, because before coming to the class, I just looked at it, and towards the end, I will just share it with you, just show it to you also, so that, yeah, look at this, right? They have used the terms electrode, electrode potential, I have told you, except for the fact that standard electrode potential. Standard electrode potential means that when the solution concentration is 1 molar, then we call it as a standard electrode potential. That's it. And after that, they have just given us a series. And with the help of that, they have, and please see, you will learn more about the electrode in class 12th. So I've just left it open-ended at this point. And if you still feel that you want to know more about it, I'm always there for you, right? And if your school teacher has taught you more, or if you are having any difficulty in any assignment or question, then you can always approach us. So from my side, I have completed the chapter. Completed means I have tried to explain the basic rules, how to solve the questions. It's you will have to spend some time with the chapter itself. All the chapters are, in fact, the entire syllabus. So to end the class, I would just like to know from you, Ritika, which will be more helpful to you, to give you an assignment on the entire syllabus, or to give on the chapters which you have recently covered, like equilibrium, redox, and thermo. What will be more helpful to you, Ritika? I'm waiting for your response, Ritika. If you have any query, anything else to say, just let me know. Even if you don't want a test, I'm open for that also. I understand you have been taught our entire chapter and the whole day I can understand your mental and physical state. But I have to make you prepare for your exams, right? Or rather, the institute has to make you prepare for the exam. So come, just tell me quickly so that we can end the class at this point.
Okay, ma'am. For the test, it's okay.
Okay. So if you have any queries, just put it on your coordinator's number. And with that, we conclude the session, and I will see you in the analysis of the paper. That means we will be giving you the chapter test, or maybe the entire syllabus test, and we'll discuss them, right?
Yes, ma'am.
Okay. So happy learning, Ritika.
Thank you, ma'am.
Welcome.